Part 2 of Lesson 27 starts now. We are on page 248 looking at the graphic of an exponential growth model. So you can see that we are starting at a value of 40. And using this, we are going to answer questions A through E. So again, if you would like, you can try these on your own, but I'm going to go through all of them. So first, the growth factor. Now, to find the growth factor, we got to use two consecutive data points. So I'm going to go, if my button will allow me here, I'm going to go back and I'm going to use 40 and 80, right? With 80 being my new and 40 being my old. So my growth factor is new over old, and I'm going to take 80 over 40, and I get a growth factor of 2. My initial value, I've already pointed out, is 40, because that's the first one they give us. And the unit measure of time, here we're talking about years. And again, we're starting in 2013, so it's kind of years after 2013. D, the exponential model. So let's remember, y equals, what are we starting with? Well, we're starting with 40. What's my growth factor? 2. And then x, where x is the number of years after 2013. So at what point will the number of life forms reach 2,000? Well, we know that they are 640 in 2017, so we kind of have to use some guess and check. We want to know the end result is going to be 2,000. Okay. Now, just to point it out, we know that when x is 0, that's 2013. When x is 4, that's 2017, because that's the data that we have. That's 4 years past. And we know that that answer right there is 640, right? That would be your y value. And we need something bigger than that. So this really becomes a guess and check, because we're not going to use logarithms, which is so sad because logs are fantastic mathematically. So I'm going to go ahead and pick something bigger than 4. I'm going to pick x equals, let's go with 6. Right? I don't know how much bigger we need. So I'm going to just try that. And if I plug in 6 for x, oops, I wanted a 6, not that. Goodness, I'm an idiot. Please excuse me. I want to plug in 6 for x. I want to know how close this is going to be to 2,000. So when I plug in 6 for x, I get 2,560. Wow! That's over 2,000. So let's back the train up a little bit and let's try 5. If I plug in 5 for x, I get 1,280, right, which is a little below. So somewhere between these 2 years is where my life form is going to reach 2,000. So let's think about what year that is. Well, at x equals 5, that is the year 2018, because 5 years past 2013. And when x is 6, that's 2019. So our answer is somewhere between 2018 and 2019, where our total life forms will reach 2,000. Does that make sense? How I kind of went through the guess and check method. Really, I think 2019 is a fine answer, because in 2018 you don't have it yet. But because, you know, we're so much past 2,000, it's going to be somewhere in between there. All right, so let's look at number 2, still on page 248, and they give us the formula B equals 10 times 4 raised to the D power, where B is the area of bacteria on the agar plate, whatever that is, expressed in square millimeters, and D represents the days of incubation. Man, look at all those typos in there. That's horrible. All right, so letter A. What is the area of the bacteria at the start of the experiment? Well, remember, the number in the front is your starting point. So the area at the beginning is 10 square millimeters. And if you just put 10, you know, I'm not going to hate you for it, but we want to get used to labeling as needed. The growth factor falls inside the parentheses here, so we have a growth factor of 4. Moving on to letter C, what is the area of bacteria after 2 days? Well, I know that D stands for days, so I plug it in, and I end up with 160 square millimeters. Very exciting. After 4 days, Well, the only thing that changes is my exponent, and it becomes a 4. So I now have 2,560 square millimeters. Notice how quickly it jumped, right? After 2 days, we were at 160. After 4 days, we're at over 2,000, right? So it's very, very quick when you're using exponential growth. Which day will the bacteria basically take over the petri dish if the approximate area is 10,000 square millimeters? So again, we're looking at, we want an answer close to 10,000. Now, we know that after 4, we have 2,560. So, I don't know. Let's check 5. Let's just see what happens if D is 5. So, y equals 10 times 4 raised to the 5th power. So 4 raised to the 5th power, order of operations, then I multiply by 10. I get a value of 10,240. And boom, I'm done, right? That is as close as I can get to 10,000, really. So it's the 5th day. So, second day it was only 160, the 4th day it was 2,500. Boom, the 5th day, the bacteria has taken over the petri dish, and you are now consumed by bacteria. Yeah, all exciting. All right. Now, the last question here on page 249, I want you to try this one on your own. See if you can get through with the information they got. It's a little bit tricky, but try it and then come back and watch them. So you estimate the growth as being 100% per month since you began. At this rate, you are sure to make money registering domain names at $9.95 each. You started this company a year ago with just one domain name, yours, that first month. Come up with an equation to represent how many domain names you registered per month in the last year. Okay, so we need a model. All right, so we got to think. First of all, they tell us 100% per month, that's our growth. So to find our growth factor, we take 1 plus the percent increase. So my growth factor is 2. Basically, you're doubling, right? It's doubling every month if you're growing by 100%. So I know my growth factor, my GF, is 2. And how many did I start with? I started with 1 domain name. So my equation, 1 times 2 to the x. Now, what does x represent? X is the number of months, because you say you are growing per month. So x is going to be the number of months. I already answered, please excuse me, part B, which is the growth factor. Our growth factor is 2. And how much will you have made at the end of next month, assuming, I forgot an M there, it has been a year since you began. Okay, so you did not pay, remember that you didn't pay for your own domain name. So I've got y equals 1 times 2. Now, it's been a year. We know that our x value represents the number of months, so I need that to be a 12 because we're talking number of months. So when I figure that out, I get 4,096. Now, that's how many domain names we've registered, but you didn't pay for your own domain name. So we're going to subtract yours out of there, and you have 4,095 domain names that people have paid for. And they paid $9.95 a piece. So after a year, you've made $40,745.25. I should put that up there. Right, that's not bad for just coming up with this product and then letting it, do its own business. All right, so letter D, if the growth continues at this rate, when will you foreseeably make $1 million? Well, we've got to go through this and say, okay, I need to use my formula, y equals 1 times 2 to the x, and I want to know when this is going to equal 1 million. So I know that after 12, I've got $40,000, right, which is not really all that close to $1 million. So I'm going to go with some big values. I'm going to go 18. Let's say x is 18. So y equals 1 times 2 to the 18th power. Now that gives me 262,144. But I've got to subtract my domain name. Don't forget that you are not paying for your domain name. So I have 262,143 domain names being paid for at $9.95 a piece. So after 18 months, I've got $1,608,322.85. Time out. I have an error somewhere. Hold up. Okay, I lied. I don't have a mistake. I couldn't read my handwriting in my own book. So anyway, after 18 months, you're over $2 million. I'm missing a number. I forgot it too. I'm over $2.6 million. That's not what I want. I want $1 million. Okay, so I got to go back. Let's use a smaller... Dang, I didn't give myself any more room. Let's use a smaller number. Well, if you use a 16, if you use x equals 16, you come up that you're going to have made $652,073.75, right? That's not $1 million. When you use 17, you end up with 1,304,000. I can't read my handwriting. I hate it when that happens. 2 raised to the 17th power. Gosh darn it. 156.45. So there you can see between months 16 and 17, you are going to hit your $1 million mark. So for each one of those, you've got to use your model, subtract 1 because you're not paying for your own domain name, and then multiply by $9.95 because that's how much you're charging per domain. So somewhere between 16 and 17 months is where you will be making your $1 million. And now I see why I was confused. I was looking at my answer for E when doing letter D. That's never a good thing. So in letter E, when will you reach 1 million registered domain names? So that is just our formula, right? When will we hit 1 million just using our formula? So when I go back, remember when I typed in for 18, I ended up with 200, that's a 3, 262,144 domain names. Well, that's too small. So if I continue, I'm going to go ahead and jump to 20. If I plug in 20 for X, right, in my X value here, I will get 1,048,576 domain names. So after 20 months, I will have hit 1 million domain names and be earning a lot of money, which is always a good thing. Well, I think it's a good thing. But anyway, that is lesson 27, exponential growth. So come back and check out lesson 28 for exponential decay. Thank you.